Assalamu alaikum viewers, please like, share and subscribe this channel. Links of PDF files used in this video are given in description. So today is a part 2 of a lecture series about metal nitrosyls, and in this lecture we are discussing different bonding situations of nitrogen oxide, nitric oxide or nitrous oxide. Up till now we have discussed two forms of nitrosyl, one neutral and other is negative. Now let's see the third form, which is NO positive, or it is also called as nitrosonium ion. So here it is nitrogen in the form of positive. So this is the valence shell electronic configuration in the form of 2s2 2p3, and in positive form what we will do removal of one electron from this place. In order to have symmetry, as in NO negative we have placed extra electron here, so in this way neutral situation is this, and in NO positive we will remove this electron. So it will make easy a comparison if we want to have comparison of these three species, so it will be easy. So this is the valence shell electronic configuration of oxygen. So this is the bonding situation between N positive and oxygen. So here these are the usual sigma and pi bonds. These are formed as it is in other NO and NO negative species, but one extra thing is there, that now this lone pair is shifted from this oxygen to here, so the cross indicates the electrons from the oxygen. The reason is that as after removal by doing N positive, this orbital has become empty, so in this way a third bond is formed between nitrogen and oxygen. It is a pi coordinate covalent bond, as these electrons are contributed only by the oxygen. So now let's see the shape of this molecule NO positive. So here we are seeing here that this is nitrogen in positive form. Now in place of N negative, this don't contain any lone pair here, so it contains only a single electron pair. Similarly, this oxygen will not have two lone pairs, but it will contain now only a single electron pair, as one extra pair that it was originally contained now has been donated towards the nitrogen through pi coordinate covalent bond. So in this way, in the geometry of NO positive, there exist three bonds between nitrogen and oxygen. One is sigma and two are pi, and among these two pi, one is pi coordinate covalent bond, which is represented here and which is represented here in the geometry. Now how the geometry will look like after bonding with metal. So here we are seeing that this one extra electron pair is donated towards the M negative. So here the geometry looks linear, and there is now a difference of IR value, as there are now three bonds between nitrogen and oxygen. So the IR value comes at a value of 1600 to 1900 per centimeter. So it means in NO negative it was 1100 to 1200, whereas in NO positive it is coming around 1600 to 1900. So from IR value we can have clear idea either NO is in positive form or either in NO negative form. Other thing was that in NO negative there was a bond angle between metal nitrosyl. Now let's see here either there exists any bond angle or not. So in order to that we have to draw the geometry of this molecule according to hybridization theory. Now let's see what is the hybridization of this molecule, and especially NO positive. It contains one lone pair here which will be donated towards the metal, and only one sigma bond has to be adjusted because other two are pi bonds. So in order to adjust one lone pair and one sigma bond, let's see how the hybridization is doing here in case of nitrogen. So this is its complete configuration, and this is N positive, so one electron is removed. So now its valence shell electronic configuration is 2s2 2p2, and this is electronic configuration written in the form of valence bond theory. This is oxygen's configuration, valence shell electronic configuration, and is written in the form of valence bond theory, which is 2s2 2p4. As we have to adjust only two species, so what we will do here, so we will do the hybridization in such a manner that only two orbitals will intermix to form two hybrid orbitals, 1s and 1p. So as we have to carry only adjustment of two species, one this lone pair and one sigma bond. So only two bonds will be involved in hybridization, one S and one P. So they undergo sp hybridization like this, whereas this py will remain as it is and pz will remain as it is. Now sp hybridization, in sp hybridization the orbitals arrange in linear form. So here two sp orbitals have been arranged in linear form. One contain lone pair and one contain sigma single electron. So this lone pair has been overlapped with m negative. So in this way here the first metal nitrogen bond is formed, and this has been represented here. Now this orbital has been occupied. Now this sp contains single electron and it will overlap with any of like px of oxygen like this. So in this way a single bond is formed between nitrogen and oxygen. Now both these sp orbitals have been occupied. Now this is the py of nitrogen which is here represented, and it will overlap with py of oxygen to form a first pi bond. So in this way a first pi bond is formed. Now this orbital has also been consumed, and in this way this orbital has also been consumed. Now what will remain on oxygen? Two lone pair are present which has to be adjusted, and one empty orbital of nitrogen. So this one empty orbital of nitrogen, it is pz and it is represented here and it is empty, whereas this is the pz of oxygen. So it contains whole lone pair, so it will overlap to form a second pi bond, but in this pi bond only one species or oxygen has donated this pi electrons in this pi bond. So this pi bond will be formed, but it will be a pi coordinate covalent bond. So in this way a pi coordinate covalent bond has been formed, whereas this 2s lone pair will remain as it is on oxygen, and it is has been written here. So in this way if we are seeing here that actually there are three bonds, one sigma and two pi. So the IR value will come at 1800 to 1900 per centimeter, whereas the bond angle between metal and nitrosyl is of 180 degree. So in this way from two points we can judge either NO present in NO negative or either it is present in NO positive. So if bond angle is angular, then the molecule will be NO negative, but if it is linear, then molecule will be NO positive. Similarly, if IR value comes around 1100 to 1200, then the molecule is NO negative, and if the IR value comes around 1600 to 1900 per centimeter, then the molecule will be NO positive. So this was all about today's lecture. I know it was a little bit lengthy lecture, but I hope you have well understood this lecture. But if still you have questions in your mind, let me know in the comments. I will respond to your queries as soon as possible. So for the time being, okay, thank you. Allah Hafiz.